Today we're looking at an object that moves in a perfect circle at a constant speed. And in class, we actually have this toy. It's a pig with wings on it. And at the top of the pig is a string, which is attached to the ceiling. And when you turn on the pig, its wings will flap and it wants to move in a straight line. But because it's attached to the string and attached to the ceiling, it has a centripetal acceleration. That's an acceleration which will change the direction of the velocity of the pig constantly. And so the pig ends up going in a circle, constant speed, but the velocity is changing technically because the direction is changing. And if you were to remove this centripetal acceleration, in other words, if you cut that string, then the pig will fly. It's going to, at least momentarily, until it hits the ground, it's going to fly in a straight line there. If we have like if we look at it, from above, that's how it will move. It'll move in that direction. If we cut the string here, it'll go in this direction until it hits the ground. But that's just the pig, yeah. So today, uniform circular motion, moving in a circle at constant speed. We have some equations here. This is centripetal acceleration. It's an acceleration, so the units are similar to what we've seen, meters per second squared. V, it's actually not velocity in this case. We're going to call it the tangential speed. Which is in meters per second. By tangential, so a tangent is a line that touches the circle only at one point. And what we mean by that is it's just the speed of the pig at, for example, at this point of the circle, not the velocity. We're not concerned with the direction, just the speed. That's the tangential speed. R is the radius of that circle, which is in meters. And T is actually the period, which is in seconds. And we should clarify this. This is the amount of time it takes the object, supposed to be a bee, to complete one revolution. So T would be how much time it takes for the pig to go and come back to that same point. Cool, and I think we have everything else defined here. Of course, that's just pi. So let's do some examples. A black car drives on a circular track of radius 80 meters. It takes the car 42 seconds to go around the track once. What is the centripetal acceleration of the car? So let's see if we can use this right away. We want to figure out centripetal acceleration. That means we need to know tangential speed, but they actually don't give us the speed. So we're stuck. We can't figure out that one. We do have the radius of 80 meters. And so we need v first. So it looks like we're going to have to do this other equation. This is a perfectly fine way to solve equations, is to see what you can solve first. So the tangential speed is 2 times pi times the radius, which in other words is the circumference, divided by how much time it takes to go around the circle, the period, which is 42 seconds. So we will just calculate this. 2 pi 80 over 42. And we get 11.97. which we could say is really just 12. But we can also say this. It's 11.97. Now we know what the speed is of the car as it goes around. So we can put 11.97 squared over 80. Cool. The centripetal acceleration is 1 point. Here we'll just say 1.8 meters per second squared. Okay. Blue car drives on a circular track at a speed of 18 meters per second. So they do give us the speed. You don't have to make a list. We don't really typically make a list, but I'm just writing that down. And the track has a radius of 100 meters. So, question A, how much time does it take the car to go around the track once? So that would be the period. And we only have one equation with period in that equation. So V is equal to 2 pi r over t. We're going to have to use this one. But we want to solve for period t. So that's kind of weird. Before we start plugging numbers into this equation, I want to rearrange this so that the equation says t equals something. I don't want t down here in the denominator, in other words. I want to move it up to a numerator, and really I want to isolate it. So it's actually pretty easy. We're going to multiply both sides by t. Ran out of space here. We're going to multiply t on both sides. So we get t times velocity, looks like TV, is 2 pi r t over t, but t over t cancels, of course, so we just have 2 pi r. And if we want to isolate t, we'll just divide by the v on both sides. That one will cancel, so t equals 2 pi r over v. If you notice, the v and the t just switched places. But it's good to show your work here. So now we will substitute 2 pi 100 over 18. We'll type that in the calculator. Oops. We get 34.9. Again, really close to rounding on that one, but I'm sorry, it's seconds. Really close to rounding on that one, but it's 34.90. So let's go to part B. What is the centripetal acceleration? V squared over R. And we can just solve it. It's 18 squared, and R is 100. We get 3.24 for the centripetal acceleration.